Hey guys, this is the start of Module 5. We're going to be talking a lot about lines and what makes up a linear function. So in this first section, this corresponds with 5.3 and 5.4 in your book, and we're going to be talking about rate of change and slope. So here's our definition of slope. It is a rate of change, which is a ratio, remember that just means a fraction, that compares the amount of change in the dependent variable, which is our y, to the amount of change in the independent variable, which is our x. So we want what is the change in y over the change in x. You guys have probably heard this term before, but a lot of times that's referred to as rise over run. Rise being the vertical change, run being the horizontal change. So if we look at this graph right here, actually I guess we'll talk about this part first. So slope or rate of change is positive if it is an increasing graph. So if it's rising from left to right, and it has a negative slope if it's decreasing, meaning the graph is falling from left to right. So just by looking at these two, this one should have a positive slope because it's rising, increasing, and number 2 should have a negative slope. Okay, so we're going to look at these graphs and actually figure out the slope. So what we need is we need 2 points. So I have 2 clearly marked, A and B, and I'm going to count the rise and the run. So rise is going perfectly vertical, either straight up or straight down. So I'm going to go up until I meet the same level that B is at. Okay, so I just went up 1, 2, 3, 4, 5, 6, 7 squares. Okay, so that is my run. So when it says rise over run, we just found the rise is 7. It's also going to be positive because we moved upward. If we were going down, it would be negative. Okay, so now I want to do the run, the horizontal change. So now I'm going to count how many spaces over to get to B. So I have to go 1, 2, 3, 4, 5, 6, 7. So my run is also 7. Now with slope, if we can reduce the fraction, we'll do that. So 7 divided by 7 is just 1. So the slope of this line is 1. You can leave it like this. That's still correct, but typically we'll reduce it if we can. All right, so, and it's a positive 1 because, again, my line is increasing. On number 2, same thing. I always like to start with the point on the left and go to the point on the right, just like we read from left to right. So again, I want a vertical piece. So this time I have to go down to get to the same level as my next point. So I'm going to go down till I'm on the same level and then straight across. So this is the rise and the run. And the rise is 1, 2, 3, 4, 5, 6. And the run is 1, 2, 3, 4, 5, 6. So, rise over run is 6 over 6. Some people like to say because I went down, I want to make that negative. That's fine. Personally, what I do is I ignore the up, down, left, right, and I just look at the line from the beginning. I knew right from the beginning my slope should have been negative, so I just work with the numbers positively, and then at the end I throw my negative sign on there if need be. Because I think it can be confusing, do I go up or down or left or right? Because I could have started here and gone up and then left. So then that up part could be confusing because that should be positive. So I like to not worry about the direction I'm moving for the rise and run and just look at the line as a whole. So again, I can reduce that. 6 divided by 6 is 1, but my slope should be negative because it is decreasing. So it's going to be negative 1 here. All right, horizontal lines. Okay, so horizontal lines are the ones that are straight across and they're going to cross our y-axis at some point. Our slope of these is 0. So we are always going to have the equation y equals a number, and this number is the y-intercept. And we're actually going to have a different letter that we use to represent that in a second. So horizontal lines are always going to be y equals a number. It's going to be whatever number that crosses on the y-axis. So in this case, the equation of this line is y equals 2 because it's crossing the y-axis at 2. Vertical lines have undefined slope, and we're going to take a look at that a little more in detail later on. But this is a vertical line, so instead of y equals, it's actually x equals a number, and that number is the x-intercept. So where does it cross the x-axis? So on this one, it's crossing the x-axis at 3, so this equation would be x equals 3. All right. Okay, so this guy is a way that we can find slope. M, the reason we use M for slope, I can't remember it at the moment, you guys, but it's a French word that means steepness or means slope. And so the French word starts with M, so that's actually why we use M for it. Also, S's are not great to use in math because they look like 5s. So we like letters kind of to use besides S. So M is a great one. So we use M to represent slope. Typically, this is the way you guys will see it if you were to ever look up the slope formula. It's the second y coordinate minus the first y coordinate over second x coordinate minus first x coordinate. Now notice this one is exactly a switch. Both of them you will result in the same answer, but notice the 2's line up and the 1's line up. 1's line up, 2's line up. So as long as that's happening, you are good to go. So here's what those little 1's and 2's mean. So you need 2 points always to find the slope. So I have 2 points here. Remember, ordered pairs are x's and y's. So first number is an x, second number is a y. So I'm going to call this x1 because it's the first x. And this is the first y. This is the second point, so I'm going to call it second x and second y. And if you flipped those, it would be totally fine, as long as you keep your 1's together and your 2's together. Okay, so I'm going to use this guy. I'll do it both ways on this top one, you guys, so you can see that we should get the same answer. Okay, so if I do y2 minus y1, I'm getting 16 minus 2 on the top. And then x2 minus x1. So notice again, I'm lining up 16 and negative 3 because those were paired together. Negative 3 minus 4. And then we just simplify. Simplify the top, simplify the bottom. So I get 14 over negative 7, which I can reduce that completely to negative 2. So I'm going to put m equals negative 2 here. Okay, now I could have done it the other direction. I could have done y1 minus y2, kind of following the second formula, and done 2 minus 16 over 4 minus negative 3. So remember, when we have two negatives right next to each other, that's going to turn into addition. So I get negative 14 over 7. And negative 14 divided by 7 is still negative 2. So it didn't matter which way I did it, I still resulted in the same slope. All right, let's try a couple more. I typically use this top one, you guys, so I like to do the second one minus the first one, but it really doesn't matter. So I'm going to do negative 3 minus negative 9 over 0 minus negative 1. And really be careful when you're subtracting a negative that you write both of those in. It's really easy to lose a sign on these because when I have both of them, it changes things and turns to addition. So this is going to become negative 3 plus 9, which is 6 over 1, which is just going to be 6. Okay. Here, negative 2 minus negative 2, so I'm doing second y minus first y, over 7 minus negative 2. All right, so again, we're going to turn to addition. So I've got negative 2 plus 2 over 7 plus 2. It's going to be 0 over 9. So I can do 0 divided by anything. 0 divided by anything is just 0. So this is going to be a horizontal line that goes through negative 2. So kind of a clue for that is if your y's are the same, you're going to get a horizontal line that has a slope of 0. This next one, notice my x's are the same, but let's go ahead and go through the slope formula process. So y minus y over x minus x. So I get negative 7 over 0. Cannot divide by 0, so this is undefined when we're asked to find the slope. And so, again, you might pick that up right away when you see your x's match. So that's going to be a vertical line that goes through 6 on the x-axis. Here's some just helpful images, you guys, just to remind you of the different slopes. Kind of that uphill look or that increasing look is always positive slope. Downhill and decreasing is negative. Horizontal slope is 0, which looks like number 5 that we just did. And vertical, we end up dividing by 0, and that is an undefined slope. All right, that's all for this video. Thanks for watching.